Hello everyone. Today we're looking at more geometry proofs, and we're specifically focusing on those angle pairs that we have been practicing over the past few days. Those corresponding angles, those alternate interior, those alternate exterior, those consecutive interior, and of course sometimes we use vertical angles or linear pairs as well. And so we're setting up a variety of proofs here that are proving some of the theorems or their converses that we just learned over the past day or two. So for example, in example 1, where it says prove the alternate interior angles theorem, we've already learned that theorem. We've already learned that if parallel lines, then alternate interior angles are congruent. We've already learned it, but we didn't focus so much on the official name. The official name is a theorem and not a postulate. Remember, a postulate does not have to be proven because it's a simple idea. A theorem is usually a connection of ideas. It's a little more complex, and so we have to prove it by connecting those ideas. And that's what we're doing today. It's not many ideas, it's just 4 ideas, 4 lines, but that's how we can prove that those two angles happen to be congruent. Now it's based upon other postulates. So if I grab the notes from a couple of days ago, you'll recognize that we've already learned the alternate interior angles theorem as an idea, but we haven't actually proven it. We haven't actually shown in geometry proof why it is that those two angles are going to be congruent. But many of these ideas are based on postulates. Corresponding angles are postulates because they're more simple, because they're in the same relative position. And these angles are not in the same relative position, so we can't call those postulates. We have to connect those angles with other kinds of angle pairs. So we're going to be using corresponding angles a lot, or we're going to use vertical angles a lot in these proofs to show how we can make these other angle pairs work. Now here we're just identifying a few key angles to work with, so it's kind of clear about where we're focusing our attention on the diagram. But if you were to compare that with the example 2, you'll notice that all 8 angles are labeled, but we're not using all 8 in the proof. It's just that we have 8 possible angles to pick from as we try to sort through the ideas. So when you have a lot of angles, even if only a few are marked, it's very important that you get in the habit, of always marking up your diagram as you go. Usually the diagrams are more sophisticated or more complicated or more detailed than what we see here in example 1. And so when you have an object named in your proof, you need to mark it here as well, so you have a visual record of what you've done so far and what you still need to show. This will become even more important in our next unit when we're working with triangles, and there's going to be lots of angles and sides when comparing two triangles. Alright, so let's go ahead and get started here. You can see that we've filled in some of the statements and reasons. Again, some of this is just a matter of matching the sequence to make the proof fit. Those are all the boxes that we'll be using to fill this in. But instead of just relying heavily on what we have here, let's see if we can think through what we would need in a proof as if we were doing it from scratch. So, we can clearly see that we are given parallel lines. First, make sure that it's marked if it isn't already, and it is. We see the symbol there. So we see that line P is parallel with line Q. Alright, what do we know about parallel lines? Well, we've studied lots of angle pairs, but we can't use the alternate interior pair yet because that's what we're trying to prove. We're trying to prove that these are congruent, and we can only go with postulates. And remember, corresponding angles was a postulate. So we're going to start off with corresponding angles, 1 and 3. Now if it's named, then you need to mark it up on your diagram. There it is. So let's create an if-then reason connecting these two together. So the if part is talking about parallel lines, so we would say if parallel lines comma, then, and I can't say then angles 1 and 3 are congruent. No, we name them on the left, and on the right we describe them in general. What kind of angles are they? Oh, these are corresponding angles. So we would say then corresponding angles are congruent. That's the corresponding angles postulate. Now that we have those marked, we can now look for some other angle pairs, such as, and here's the hint, we're talking about vertical angles now. Look at angles 3 and 2. Okay, we know angle 3 is congruent with angle 2, don't we? Because if two angles are vertical angles, then they are congruent. So if you've named it, mark it. And then all of a sudden you realize, hey, if 1 and 3 are congruent, and 3 are 2 incongruent, then what do we know about those alternate interior angles? They have the same symbol, therefore they must be congruent. So if you've marked it, name it, and now we want to determine what allows us to say they are congruent. There's only one box left we haven't used. You can see it's a transitive property, but do you see why it's a transitive property? We have angle 1, we have angle 2, and angle 3. We've got 3 ingredients. That always shows up with the transitive property. If the first angle is congruent to angle 3, and angle 3 is congruent to the second angle, then what do we know about the first and the last? They are also congruent. So you can see that from the first angle and the last angle, that's your transitive property of congruency. For this next example, we are going to prove the alternate exterior angles converse. Alright, so again, we've already studied this from the previous day of notes. We've learned that the alternate exterior angles converse says if alternate exterior angles are congruent, then the lines are parallel. So we've already understood the big idea, but a converse is like a theorem in that in order to prove it, we have to connect a variety of ideas together. And that's what we're doing here. So we already know that if we have alternate exterior angles are congruent, see me marking up the diagram, then the lines will be parallel, but the question is why? Why are they parallel? Again, the trick here is to find other angle pairs that are either based upon vertical angles, because we've studied that before, we can use vertical angles, or corresponding angles, because that comes from the postulate, and because that's a simple idea, we can always use postulates very easily in these proofs. You'll notice in this proof that we have 4 blank spaces, but we have 6 boxes, and that's because there are several correct ways of solving this proof, and depending on which way you go, you'll use one pair or the other of these 4 angle pairs. Oftentimes, the way we structure these proofs with certain pieces filled in or certain boxes, it leads us to think that there's only one way to correctly fill out a proof, and that's not correct. There are many ways to do proofs, and so we're trying to show you that there's a variety here just by putting more boxes on here. So, where should we start? Well, of course, we've got the given to fill in on reason 1. And we already have the given information here. It's labeled, we've marked it, we're now ready to go. Remember, we're always trying to focus on vertical angles that we can use or corresponding angles. And here we're setting us up so that we can work with a vertical angle pair. Now we want to pick a vertical pair using an angle we've already identified. So it would be pointless to use angles 1 and 4. I mean, clearly they're not even marked in the boxes as an option. Even though 1 and 4 are vertical angles, they're not going to help us because they're not based on connecting with the information we started off with. We have to either focus on angle 2 or angle 7, and it's vertical pair. And you can pick either one, it doesn't really matter. So I'm going to pick angle 7 and 6. So I'm going to use this box right here, and that's going to say angle 7 and angle 6 are congruent because they are vertical angles. So I've marked it on the diagram. we have to write it down as well. So angle 7 is congruent with angle 6. Now you'll notice that we have 3 angles labeled so far. We've got an angle 2, we have an angle 7 showing up twice, and we have an angle 6. That's 3 ingredients. That means we have the transitive property, right? So if the first angle is congruent to the second, and the second angle is congruent to the third, then what do we know about the first and the last? We know that angle 2 will be congruent with angle 6. So the reason why we know they are congruent to each other is because of the transitive property. Now you might look at these and say, wait a minute, but they're also corresponding angles. Yes, they are. We're going to use that in the next reason, but we couldn't say they are corresponding here because we don't have parallel lines yet. We're trying to prove that the lines are parallel. So now we're going to say, if these are corresponding angles and they happen to be congruent due to the transitive property, then what does that mean about the lines they touch? So now you want to think of an if-then, saying if, and now you have to name the angle pair, if corresponding angles are congruent, then we have parallel lines. Now you can see then from the boxes we picked the angle pair of angle 7 and angle 6, and with the transitive property we picked these two. We could have done the other pair, and that would have focused on the vertical angle that is vertical with angle 2. So we could have used these two angles, for example, and then we could have used these two angles as our corresponding pair. So that's why there were a couple of different options in which way we went. Let's turn the page and take a look at the next proof. With example 3, it just says complete the proof, so it's not actually indicating if it's any particular theorem or converse we're trying to prove, and in fact it's not, because here you see the diagram is quite different. We have not just 2 lines and a transversal, but we have 2 lines and 2 transversals, and that makes the diagram more complicated. So there will be times when I'm stepping away from the proof to go down to these additional diagrams just to emphasize certain parts of the original diagram that we want to focus our attention on. Again, I'm going to be ignoring the boxes for the most part because I'm trying to talk you through how we would think through the proof, how do we try to make connections and think it through, because that's what you'll have to be doing on your own anyway. But if you look more closely, you'll recognize we have 6 blank spaces and 7 boxes, and that's because one of these is a decoy. So if you were to try and go through this on your own, you would find one is being left out because it's not to be chosen. Remember, always mark up your diagram. So if we are told that line X is parallel with line Y, you need to make sure that you find it and then mark it. So we put those arrow symbols on the lines. We're also told that angle 1 is congruent with angle 3. Angle 1, angle 3. So always mark the diagram with the given information, and if it's been marked, it has to be named. Well, that would go in line 1 anyway, of course, because we always have to start with what we've been given. So we have 2 pieces of given information. Let's focus on the lines first, because we've studied a lot of angle pairs based on parallel lines. So what we're doing here is taking a look at this diagram, and this diagram is trying to highlight line X and Y because they are parallel, and they're trying to emphasize line A, and they're trying to hide line B, so pretend it's not there. Alternatively, just take a scrap piece of paper and cover up the right side of the diagram so you have 2 lines and 1 transversal. We could do that on this original diagram here too. We could emphasize these 2 lines and highlight this 1 transversal because we've learned something about this angle pair. And that's what this diagram is saying. It's saying, hey, if you have 2 lines cut by a transversal, then don't we know something about these two angles? Yes, we know they are congruent. So you have to name it, and then you have to write the if-then statement for why we know it's true. So think of an if-then that combines these two parts. So if parallel lines, then, now be very careful, we can't just say then angles are congruent. That's not specific enough because we've learned about lots of kinds of angles, like vertical angles, complementary angles, supplementary angles. What kind of angles are they? So that's why you look at the diagram and say, oh, they are positioned outside to the exterior of the two parallel lines and on alternate sides of the transversal. So these are alternate exterior angles are congruent. So I often see when students are trying to fill this out without the aid of the boxes, sometimes they will mistakenly leave out the type of angle pair, or sometimes they will remember the angle pair, but they'll forget to say it's congruent. Like if one of these details is missing, then it's an incomplete idea, and it wouldn't provide for full credit. Alright, so now we've marked this secondary diagram with these two angles. We should really do the same with these two, because remember, we were given that 1 and 3 were congruent. Now we know 2 and 3 are congruent, and because of the similar marking pattern, we can now say, hey, angles 1 and 2 must be congruent as well. But how do we know that? So again, this is our transitive property because we've got 1, 2, 3 different angles. And when we have 3 items, and we link them all together, that's our transitive property. So if the first angle is congruent to angle 3, and angle 3 in turn is congruent to angle 2, then what do we know about angles 1 and 2? So we're taking angle 1, and we're taking angle 2, and we're saying they are congruent to each other because each of them are congruent to the same angle 3. And of course you can see on the diagram, that's why it's so helpful to mark up your diagram as well. Transitive POC, property of congruency. Now obviously we're trying to prove lines A and B are parallel, and we're at that stage now, but the important part is, do you understand why they are parallel? And that's what this next diagram is for, so kind of step over here. Because what we're emphasizing now is take a look at angles 1 and 2, that's what we just determined, and we can see that these angles are corresponding angles. They're both in the same relative position, up and to the right. So what do we know about corresponding angles and the lines they touch? If the corresponding angles are congruent, then the lines they touch must be parallel. And so that's why A is parallel with B. And again, we want to think of an if-then statement to connect those ideas together. So if, now be careful, you can't say if angles are congruent. That's not specific enough. We have to name the angle pair. If corresponding angles are congruent, then we have parallel lines. Alright, and here's our fourth example. And on this last example, once again, we are going to try and prove that these lines are parallel. So they're not parallel yet, but we're going to take some information about supplementary angles and work our way through showing that these two lines must be parallel after all. Now again, there's no symbol to show that two angles are supplementary, so we could mark it up maybe with an asterisk, for example. So if I were to put a little asterisk on angle 1 and angle 6, that will help us just to keep track visually of which angles we're talking about. Notice these angles are none of the pairs we've studied. These are not corresponding angles because corresponding angles would be in the same position. So 2 and 6 are corresponding, or 1 and 5 are corresponding, but 1 and 6? No, those are not corresponding. Notice angle 1 is an exterior angle, it's outside of the two lines, and angle 6 is an interior angle. So again, we don't have an interior pair, we don't have an exterior pair. These are none of the special angle pairs we've learned about. So that means we're going to try and connect one or both of these angles to another angle, either by using vertical angles or maybe corresponding angles, because that's a postulate. And through that method, either vertical angles or corresponding angles, find another angle pair that we can use instead of 1 and 6. Alright, so of course the given information is already marked down. There's our reason given. And we know something about supplementary angles. We know that that means they are angles that have to add up to 180 degrees. So think of an if-then statement that we could use. If two angles are supplementary, then they add to 180 degrees. That's the definition of supplementary angles. So as an alternative, you could have just written definition of supplementary angles, if you like that official title better. But if you don't memorize that, again, the if-then is what we try to work with as we build it off of the structure of our statements. Okay, here's a little bit of a hint as it says, okay, now we're going to transition. Notice that in line 2 we had an equation, but in line 3 we don't have an equation. So it's like we're transitioning ideas. So there is no if-then to be made here. This is something new. So that means let's go back to the diagram and see if we can figure out something going on with angle 1 and angle 4. Why are they congruent? They're congruent because they're vertical angles, aren't they? So if two angles are vertical, angles, then they are congruent. Alright, so from line 1 we were talking about supplementary angles, and we understood the definition of supplementary angles meant that two angles had to add up to 180 degrees. That's how we got an equation on line 2. But on line 3 there is no equation, so that's how we know it was a break, and this is a brand new idea we're bringing in. It does not have to do with supplementary angles, it's something else entirely. We've marked the diagram, we've got the angles by name, we understand that they are vertical angles. But because we have an equation on line 2, I need to continue working with this, but I can't if I have the congruent symbol. So the next step is to take line 3 and change it so that we are talking about the measures of angles 1 and 4. And we know that if they are congruent angles, then they must have equal measures. So this is the if-then statement that you see, the if-then reason that you see on line 4. So if you think of the if and the then for this pair, we're saying, well, if two angles are congruent, then they are equal in measure. And there it is. So this is your definition of congruency, and you can use that official title if you prefer. You can see that with the hint given here on reason 5, we're doing a substitution, and it's a property of equality. That means keep using the equation. So we need to think of an equation that we're going to write, and we have to make a substitution into that equation. Here's the equation we're talking about, the supplementary pair. And we're going to take this equation, write it on line 5, but make a substitution. So you can see that we're talking about the measure of angle 1 plus the measure of angle 6 equals 180 degrees. These two. We're going to take angle 1 out and replace it with angle 4 so that we can then say that these two angles are adding up to 180 degrees. So what we're doing is we are taking this angle 1 out, and we're going to replace it with angle 4, because 1 and 4 are the same size. So the measure of angle 4, that's the substitution we just did, plus the measure of angle 6 equals 180 degrees. So what we're saying now is that angle 4 and 6 are a supplementary pair, and so, just to kind of keep track of it, I'll put a little asterisk here on 4. So I have to be careful. I'm not saying 1 and 4 add up to 180. No, those are vertical angles. We know those are congruent. We're saying 4 and 6 will add up to 180. And as we take a look at that, we can say, hey, that is one of the angle pairs we've studied. That's a pair of consecutive interior angles. And if those are supplementary, that's what makes the lines parallel. So as we finish this off, again, think of an if-then to create your reason for line 6. How do we know that angles 4 and 6 are supplementary? Well, we know they're supplementary because they added up to 180, because we did that substitution. So if two angles add to 180 degrees, then they are supplementary. Now if you compare reason 6 with reason 2, notice that's exactly the same, but in reverse order. If two angles are supplementary, then they add to 180 degrees, versus if two angles add to 180 degrees, then they're supplementary. Remember, definitions are always true both forwards and backwards. So this is your definition of supplementary angles. And again, you could have just used that official title if you wanted. So now we say angle 4 and 6 are supplementary, and the reason why they create parallel lines is because they're not just supplementary, but they are consecutive interior angles that happen to be supplementary. So we do know that these lines are parallel, and we have to again think of an if-then statement connecting these two. So we would say if, so again, watch out. Don't say if angles are supplementary. You have to name them. What's the angle pair? If consecutive interior angles are supplementary, then we have parallel lines. And that's that.